Hello everyone. Hello. Good evening, Afsal. We'll be starting in 2-3 minutes. Let everyone join in. Then we'll start. Till then, just tell me. I hope that I am audible to all. Good evening, Samiksha. Good evening, Prashant. Hello everyone. So yesterday we talked about arrays and how do you declare them. We were discussing some things about vectors. We also talked about a very popular problem known as two-sum problem, where we kind of introduced about how do we use hash maps, hash set, why do we use them. You will see in like the most of the cases, whenever you want to like decrease the complexity, these data structures actually help a lot, these hash set and hash map, because the uniqueness in them is you can find any element in O of 1. That's the beauty of hashing. uh, that's what we did. Today we'll be doing some 3-4 problems that depending on the pace of the class. We'll see. Good evening, Mohan. Good evening, Vinod. Good evening, Reshma. Yes, Prashant, we'll be talking about two pointer or sliding window uh, problems. Just not right now. We need to cover some more preliminary problems, for example, maximum subarray or maximum product subarray. Uh, Actually, maximum product subarray is sliding window problem. But maximum some subarray, which is of cadence algorithm, we have to look into it, and also some more standard and famous problems like sub equal to k, or best time to buy and sell the stock, or like these things. Good evening, Namrata. Good evening, Devika. Yes, Benarji, you are right. That's why two pointer and sliding window are used. Good evening, Devika. Good evening. Yes, we are starting just in a second, I think. Let everyone join in. We will start at sharp 7:07. Till then, let me just show you what will be the first problem of the day that we will be solving. So, okay, let's start. This will be the problem that we will be solving. I think I should zoom. So look at this problem. Try to see, can you can you figure out the algorithm by yourself, and try to tell me any observation, any amazing observation that you are trying to extract from this problem. Because see, uh, whenever you're trying to solve a problem, right, keep a pen and a paper with you. Try to extract some 2-3 valuable observations from that problem. Like today only, I was doing a problem from Code Chef, and this technique really helped. Like I was just noting down my observation. Okay, so uh, now obviously I will not discuss the whole problem here because it was a little tricky problem. But I was just noting down my observations, whatever I was observing. I was just noting down. I had a paper and a pen. I was noting them down, and while noting them down, I realized, okay, I there was a point where I wrote something like three conditions, And those three were actually enough for me to devise an algorithm such that I could use those three observations to come up to a deterministic algorithm, right? So that's sometimes a very useful way to solve these puzzles. Like, because these puzzles are not, like, you cannot give an excuse ke I don't know DSA, so I will not be able to solve them. There is no need of a DSA, right? Just uh, you just need to know how vectors, how do you initialize a vector, how do you access a vector. That's too simple. That's too simple, right? That's too simple than a applying Dijkstra or applying dynamic programming. So let's see this problem. You are given an array prices where price I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot, okay, try to see some of, let's try to see best time to buy or sell, to buy and sell. Okay, I should share my screen right now. Hello, let's try to solve this problem. So, okay. So one observation which we can make is uh, buy one stock at ith day and sell it at jth day such that j greater than I. So this is very important, and this is very important. Like, I'll just highlight them. This is important, and this is important. You should be able to see these things. Okay. So you just want one, um, you just want to choose only two indexes, I and j. J should be greater than I. Why? Because of that keyword that we want to sell it in future. Okay. So we know these two things. Okay. So ideally, answer would be this. We want to maximize prices of j minus prices of I. Okay. Okay. How do you do that? How do you maximize this expression? It is important to understand this. Okay, so one possible way is pretty simple. Can someone give me an n square solution to this problem? try to think of a n square solution for this problem. If you guys want to see the problem again, here is the problem. Correct, Rahul. You are absolutely correct. We can simply loop through every pair of I and j. We know how to do it. We can just use two nested for loops, two for loops, and we can loop through every pair of j and I and j, and we can calculate it. Okay, but let's look at the constraints. Constraint says 10 is power 5. The size of price can go till 10 is power 5. So that this we know that yes, yes, Prashant, you're right. Uh, such that j greater than I. We know that O of n square is only valid till n is less than equal to 10 raised power 4. So we know that n square solution will not work. So we already figured out an approach which was loop through every pair of I comma j and take maximum. Okay. Now the point is we need to we need to we need to optimize this. How do we optimize this? So see, if you fix this entity, think about this. If you fix this entity, prices of I, prices of j minus something x, it is same as maximizing this is equivalent to something I'm going to write here. Prices of j minus minimum of x for all j. Does this make sense? Now I realize that this might be a little confusing when it comes to math. Let's take an example of any random example. Okay, let's say example there we have 7 stocks, n equal to 7. Prices array is something like this: 4, 5, 6, 10, 2, 1, and then we have 11. Got it. How can we do this efficiently? What we can do is we can keep a global variable known as minimum initially assigned to be 4, because this is 4. Okay, and now we start from this element. We go to 5, we see the answer can be 1. So we keep updating our answer variable, and the rule to update it is actually this is, let's keep it x is equal to 4. Okay, so at this index the best bid we have is 5 minus 4, 1. What we are doing is we are maintaining a global minimum array. Okay, now we update this, it keeps it it still stays 4, because how do we update it? We take the minimum of the current element. Okay, And now we again see the answer comes out to be 2. So we update the answer to be 2. Again, nothing to be updated. X stays to be 4. What we are doing is we are just taking the minimum of the traversed array. Because see, logically, what I'm doing is I'm choosing an index. I'm saying, okay, whatever happens, I'm going to sell at this index. I'm going to sell at 10. I'm going to sell at 5. What's the optimal position where we should have bought? The optimal position is till this ith, whatever I'm selling at. Let's say I'm selling at this. Whatever ith index I'm selling at, till that, what's the minimum? Because we need to buy at the minimum and then sell at this element, right? At this index. That's the strategy I'm imposing. So again, the answer gets updated to 6. Now again, nothing to be updated here. The 4. Now the answer doesn't get updated because what we get is 2 minus 4 minus 2, but our answer is already 6. So we don't need to update our answer here. We just put 6. But we need to update our minimum. The minimum becomes 2 because now we have found a better position to buy the stock. Okay. But again, we don't update our answer. Why? Because 1 minus 2, it's still minus 1. And the answer still holds to be 6. It's greater than minus 1. So we don't really need to update it. It stays 6. Now see clearly. Clearly now minimum gets updated again because we again found an element, a better position to buy the stock. This is a better position to buy the stock, right? And now the answer gets updated to 10 because 11 minus 1 equal to 10. So the answer is, in this case, the answer is this 10. So again, the new approach that we figured out is maintain a global minimum of a no. If we are using prices, then let's use prices. Prices 0 to I and update global minimum. We are calling it X and update answer as answer equal to maximum of answer prices I minus X. See clearly in such in whenever when we got rid of I variable here, right? We just focusing on J. Here we are focusing on both the elements, so we needed 2 loops. We decomposed it into 1 loop. Yes, Rahul, you are right. Uh, try to code it. Try to code it and try to understand it. Yes, Palak, I will explain it again. Try to understand what I have just said. Try to code it up. Uh, till then, I will just wait for other people to ask their doubts so that I can clear those doubts in one go. Just tell me if you have any doubt. Okay, Shilpa, I will explain again. Not a problem. Yes, Harshita, it will show limit exceeded. Okay, I will explain again. No worries. Okay, let's try to code it. I hope that most of your doubts will be get cleared while I'm coding it. If you still have any doubt, then you may ask. Okay, let's code it first. So just as we discussed, we'll maintain an array named x, which will hold minimum. So p of 0 is the minimum for now. And again, the answer variable, which will store answer, which is planned to be 0. So for int I equal to 0, I less than p dot size, I plus plus, answer equal to maximum of answer comma p of I minus x. Okay, maybe we should not use variable names like x. Okay, we should use variable names like this: current minimum, answer, oops, answer, current minimum, and this is prices, prices. Okay, I think now the code is more readable. And current minimum equal to minimum of current minimum comma prices of I. Now we simply return answer. Let's see if it works. Oops. Oh, what has happened to my vocabulary? Um, Oh, so many errors. It works. For now it does. Let's try to submit it. Yes, it works. So just tell me if you have any doubt in implementation in the I think just tell me the any doubt if you have any doubt in algorithm. Do you have any doubt how we have decomposed it into O of n? Okay, let's just change our answer variable to max profit. I think now it's super readable. Give clarity on final answer. Okay, so see the I think Banerjee has a doubt still. Okay, so see here we started with one observation that we need to buy just one stock, okay, and sell one stock. Okay, there is no complication of buying or selling multiple stocks. First of all, second of all, obviously we want to sell them in the future, right? So J should be greater than 1. There are two observations. Now we need to maximize this equation. Maximize price of J minus price of I, uh, such that J greater than I, right? But we realized that this is a solution having n square complexity. So we disregard this solution because it will not work. We try to do some cleverness. We say for every index, we just need to minimize this element, right? Think trivially. Think trivially, right? If you want to sell a stock, right? Obviously, we'll sell it in future. First you have to buy it. Let's say you're fixing the position of selling the stock. You know, I have to sell it at ith day. Then what the problem becomes? The problem becomes finding an index a day earlier than the ith day, such that your profit maximizes, right? So think like this. find X such that profit maximizes for every j. Do this for every j, for every element. And what can be that best X? What can be that best day? Obviously, it can be the minimum, the day when the price of the stock was minimum. You buy on the day when the price was the minimum, and then sell it when the price was price of j, right? Exactly. So you sell at, you're fixing the day when you are selling the stock, and then the whole point becomes just find the minimum, the day when the price was minimum. That's the simple strategy, and that's what we are doing. Now, don't confuse yourself by finding a minimum of global minimum of the array. We don't really need to find global minimum. We need to find the running minimum. Why? Why the running minimum? Because this was the condition that the question says that you can only sell it in future. So when you're fixing the selling position, you need to find a position such that the price is minimum and that position is less than that fixed position of selling the stock, because obviously you will sell the stock after buying it, right? So you have to buy it before selling the stock. That's why we are using a running minimum, we call it. Running minimum is known as the minimum till you have traversed the ith integer, ith index of that array. I hope that uh, it's clear to everyone. I can just explain the code again. I think some people are asking for the code. So this is our current minimum, running minimum. For now, it's initialized to prices of 0, because we know we are not going to prices of 0. Why we are not? We can even start with 1. Why? Because we know we'll never sell at the first day, because there is no day to buy it, right? So first day can never be the selling day. So we are always starting with the second day. Here it is 1 because the array is indexed with a 0 based indexing. So, and this is our maximum profit variable. Now we know that we are fixing a price I to sell. This is a day where we sell. So I can even make it more readable. In price at selling day equal to prices of I. And now you must realize that our algorithm kind of makes a lot of sense, right? If first day is maximum, they should submit. Yes, it submits. See, if the first day is maximum itself, if the first day is maximum, it doesn't really matter because there is no day left to buy the stock. So first day can never be uh, the selling day, right? That's why we can start the loop with 1 and see clearly. When I started the loop with 1, I reduced 1 iteration and our solution is now a little more better. So I hope this solution is clear. Let's jump on to the next problem. The next problem will be this problem. Subarray sum equals k. Uday, you cannot use maximum and minimum. Like, see, I'll give you a perfect example of why can't you use maximum minimum. Hmm, just look at this for an example. Okay, so there is a question asked by Uday. Why can't you simply use maximum and minimum? Okay, so why can't you use maximum minimum? The answer to this question is, I will just give you a counter example simply. Okay, Counterexample is, can we fit any counterexample from here? No, we can't. So your answer will be equal to 10 and actual answer will be equal to 3. Why? Because you will simply see maximum is 11, minimum is 1. You will do 11 minus 1, which is equal to 10, which is not possible. What you're basically doing is you're saying, I will buy here and I will sell here. You cannot do it, right? They're simply saying you can only sell in future. This is important. This keyword was important problem. You can sell in future. So you know whenever you are buying, sell will be ahead of buying, right? So you cannot do this. There can be a case while doing maximum minus minimum, when the maximum falls behind minimum, it occurs behind minimum. That's when your approach um, that's when your approach fails. So your answer will be 10, 11 minus 10, but it's not the correct answer. It's actually 3. You buy here and then you sell here, right? Okay. So let's try to solve this problem. Uh, Try to see this problem. Devika, I am coding on lead code. I'm not using any explicit ID to write my code. I'm just writing it directly on lead code. Otherwise, I use VS Code to write codes. Just tell me when you guys have uh, read the problem thoroughly, you have understood it. And again, try to mark some observations, whatever you. This is a like these problems are really great to practice to master that skill of you know writing down your observation. Because see, right now what problems we are doing, the problem statement is not that big. See, the problem statement is small, and trust me, um, once we go to the third day or fourth day of the boot camp, the problem statements will start getting bigger. So try to build this habit. Try to build this habit of taking a pen and paper and trying to write your observations on that pen and paper, right? Sub array sum equal to k. Um, this is a really interesting problem, um, and this is a very like influential problem in the sense these type of problems actually influence the uh, the type of problems asked in modern day contest as well. Like these are some standard problems. These are easy problems. But why do you need to do them? The reason is there are contests which take inspiration from these problems and then the problems are asked with minor tweaks. See, I'm just deviating for a while. I'll just give you one example. The example will be from Code Forces. So Code Forces um, recent Code Forces round was held, and see this problem. It was like really um, like related to what we are going to do now. See, they're also asking for a sub array whose sum is equal to s. What we are doing is sub array whose sum is equal to k. They are also asking count the number of such segments, yani ki count the number of sub arrays. We are also doing counting the number of sub array with sum equal to k. They have just added another functionality which makes the problem a little tougher. Also, the maximum of that sub array should be x. Don't bother about that as of now. But see, can you realize that they are taking inspiration from a standard or a classical problem? So that's the main agenda behind doing these classical problems. They actually help you to build your intuition on these classical problems so that you can tackle more advanced problems, because advanced problems are just a build up upon these classical problems. Okay, so let's not deviate much. Let's be back on. Try to read the problem statement till then. Okay, so the attendance link is in the chat. Guys can mark your attendance. No, Nitin, class is not ended. I think yesterday I put this link in the very end. So today I decided to put it in between. I think most of the students actually just come for the attendance, so they must be thinking that the link will be put in the end. So I'm just putting it right now. Okay, so you guys can mark the attendance. Till then, we try to solve this problem. Okay, so what are the observations which I am getting from this problem? The problem that we are going to do now is Sub-array sum equals k. Okay, so there are some observations. The first observation, think about it. What can be the observation, right? So let's just, before jumping on the observation, I'm just trying to see how can I make you realize that observation. Okay, let's say this subsegment, the sum of this subsegment equal to k. So what can be done? We can say this and this. Prefix of I minus pref of j equal to k. What is pref? Pref is the cumulative sum from 0 to that index. Cumulative sum, okay. Cumulative sum, what does cumulative sum means? That sum of all the elements. Sum of all the elements. Okay, so we understand this, right? Sum of all the elements in this range, if we subtract them from this range, subtract the elements in this range, we will get the elements in this range, right? We know it. So we can do something like this. Okay. Again, there is a n square approach in my mind. Can you guys think of an n square approach? Yes, Neha, I will explain, but try to think of an n square approach for this problem. O of n square approach. Try thinking of an n square approach. So one n square approach is simply try for all I and j. Simple as that. Do this for all I and j. Right. But that's not optimal. Okay. Uh, no, George. We'll be discussing this problem. So just stay for a while. I will not take a lot of time. Try to think about how can I optimize this. I found an approach. So one approach, if I may write it down here, check for all possible pairs of I comma j and see if this condition satisfies. The condition is prefix of I minus prefix of j equal to k satisfies. Okay, try to think of an approach. Okay. And see, we can these type of approaches where you are checking for all possible pairs, they're kind of two pointers, right? You're just pointing two pointers and checking certain conditions between them. These are kind of how two pointer approaches work. We just uh, these are a very naive way of uh, implementing two pointers. There are more amazing ways. The more amazing ways are where this pointer traverses the whole array and this pointer traverses the whole array. Hence, we say the complexity is just 2 into n, which is also O of n. That is the beauty of two pointer. We'll discuss two pointers, but okay. So what I see is now let's make another one. I only care about if prefix of I minus k occurs and how many times. See, the equation was prefix of I minus prefix of j equal to k. So I can write it as prefix of j equal to prefix of I minus k. Okay. So I simply need to check if I have this element prefix of I minus k. Do I ever encounter this element? What's the most efficient way to check if a value occurred or not? Quick in the chat. What's the most efficient way? What's the most efficient way to check if an element, a value occurred in the array or not? Most efficient way. Try to think about it. Which uh, which data structure can we use such that we can find if a particular value occurred or not? Exactly, Altaf. You are absolutely correct. Hash map. Hash map is the answer. We can optimize it using hash map. We can simply ask, tell me, does this value occur? Now think about it. Do we really, what do we care about? Do we care about this question if it occurs or how many times it occurs? Read the problem statement. Sub-array sum equal to k. You have to give number of sub-arrays such that sum equal to k. We have to give number of sub-arrays. So what do you think? Which question should we ask? Should we ask if prefix of I minus 1 occurs or should we ask how many times it occurs? Exactly, Bhavya. You're absolutely right, Bhavya. We care about how many times it occurs, right? So simply we know that we will be using hash maps. Let me just dry run one. Okay, let's try run this. 1, 2, 3, 3, 6. This is our array. K equal to 6. And this is our map. Now let's check. 1, we do 1 occurs one time. We know that 6 minus 5, 6 minus 1 equal to 5 and 5 does not occur. So right now we are not updating the answer. Now we go here, we make it 3. 3 occurs also once. We check 6 minus 3 equal to 3. 3 does not occur. Okay, so we have to check it before updating, right? Because see, now my algorithm will say, okay, 6 minus 3, 3 occurs, right? So it will add 1. It should not add 1. It is counting these 3 two times. It should not do that. So basically we should update it after checking. First we check if 6 minus 3 is equal to 3. Is 3 there? No. Okay. We don't update it. We just write 3, 1. Now we check 6. Okay. Now we check if 6 minus 6 equal to 0 is there. 0 is not there. Okay. I kind of figure out a flaw. This segment sums up to 6. Then why am I not counting it? Okay. So now I realize I should maybe add one entity which is 0 before even traversing the array, right? Because an empty subarray, when I didn't traverse anything, think about this. When we were here, we didn't traverse anything. What do we have? We have 0. Think like the subarray is like this. Because an empty subarray, if we don't have this, the sum is 0. And we know it trivially, right? This should be counted as an answer. So this we will initialize. Okay. And so I will mark my answer. Let's mark our, this is the value of prefix. This is the value of answer. It was 0 here, it was 0 here, it becomes 1 here. Okay. We see 9. Now 9 minus 6, 3. We see that we have one occurrence of 3. So we again increase it by 2. And we can see it trivially also, right? This is an answer, right? Okay, just give me a second. Yes. Okay, now it's visible. So we know that this should have been an answer. So we know that this step, that increasing the answer by 1, is correct. Again we see it becomes 15. Okay, now again we have to also do this. Also we have to do, we check if 15 minus 6 equal to 9 is present. Yes, it is present. So we add this 1 to here. Adding 1, it becomes 3. Explain again. Bhavya is saying explain again. Okay. Okay, a lot of people are saying explain. Okay, Vidhi. Okay. So what I'm doing is I'm storing the cumulative sum. Okay, till ith element. Now let's say the cumulative sum is 9. What do I need? I need a 3. Why do I need a 3? If I get a 3, what does 3 depicts? 3 depicts the sum till here. What 9 depicts? The sum till here. If I subtract them, this means the sum between them. If I ever get a 3, this means there is a subsegment whose sum is 6. Because this endpoint is 9, this endpoint is 3. This means starting from this segment, this star, to this star, the sum is equal to 6. Yes, Ayush, yes, I understand. I understand there was a blue screen. So I am explaining again. I am maintaining a prefix array and I'm maintaining a prefix variable and a global variable answer. See, the question what I'm asking is at every ith index, I need this prefix of I minus k. Okay. I need a prefix of I minus k value, and we already discussed the best optimal way to search for if a value existed or not is hash map. We agreed it on the chat. You guys only suggested me. So hats off to you guys. You guys figured it out that we should be using hash map. And you said correctly hash map. We don't really need hash set. Hash set will not help. Why? Because we also need to count the number of occurrences, right? We just don't need to answer if there is an occurrence or not. We need number of occurrences. So we need hash map. Exactly. So that's the question I'm trying to answer. Let's try to code the solution now. It will be really simple to code it up. Um, Let me just simply full screen this. And then, okay. So, okay, we need an ordered map, int comma int, and we call it frequency, frequency map. And we need a cumulative, cumulative sum equal to 0, answer equal to 0, will score frequency equal to 1. Why? The reason for this we already discussed. Empty subarray has sum equal to 0. For int I equal to 0, I less than a dot size, I plus plus. What we need to do, we need to update our answer frequency cumulative, and we also need to update our cumulative sum to AFI. Let's check if our solution works. Okay, so it works. So I hope everything is clear to everyone till now. Uh, Today's session ends here. Whoever has any doubt can ask me the doubt. The session is over as of now. I will entertain some doubts if you guys have any. Atmira says if you can. Okay. Yes, I will share the notes. Okay. So what we needed was we needed a cumulative sum, and we are maintaining a frequency map and storing our answer in the global answer variable. Try to think about this problem. Again, I will take try to think it on your own. If I'll try to like spoon feed you, it will not help. So try to think it on your own, and then come tomorrow at the same time. We'll meet at 7 p.m. And ask me whatever doubt you have in this problem. Right? Okay. Okay. Bye, everyone.